Good morning, everybody. My name is Andreas Jäger. I work for SUSE as a product manager. I'm also involved with the OpenStack project, where I'm a core reviewer for the infrastructure and documentation teams. And I have with me Thore Bahr.
Yes, good morning also. I'm working as a system engineer for SUSE, involved in most of all the cloud projects here in Germany, and will give us some details on this later.
Okay, thanks, Thore. Thanks, Mark, for your keynote. You spoke about how OpenStack is used as an integration engine, and we didn't talk before what you are presenting or what we are presenting. We want to talk build on top of what you said before and also showing some use cases how you can use that integration engine in your own data center to move forward. So we will look at a couple of customers, what they are doing with OpenStack, but also share some of the lessons that we learned implementing OpenStack in different companies that are using it today or are in the process of going there very soon. If we look at the data center today, we often have a view that is very ideal, how it should look like. And that's how we would love to have all the applications working. Everything is fully automated. There's a really fast response time. And we have only the new workloads called Kettle. But we all know reality is different. There are many so-called pets, different applications that you have to take care of, legacy applications that you have to take care of, and those want to run forever. And as Mark mentioned, companies, while they might go with OpenStack stepwise to implement it and get it running in their data center, in the end they most want to have everything running there. So those need to be migrated somehow. And operators and users most often like what they have. So they want all the good things they have, plus faster for going to the data center. And they have little automation, so some of that getting faster, some of that self-service is a challenge and needs changes going forward. And a question that you will ask yourself is, how can we help migrate from that reality of the data center today to the ideal world, to a faster self-service and so on? And also, if you're a developer, how can you help your users, how can you help OpenStack users go in that direction? If we look at cloud usages, there are different ways of how companies introduce an OpenStack cloud. Some introduce it as an enhanced virtualization. So basically, when I talked first with a customer about that, I was saying, that's not OpenStack what you're doing. It's completely different. But they basically put into the data center OpenStack, but to the outside, to the internal users, it's the same old interface, it's the same workflow, the same approval process that currently takes perhaps 2 months or 2 weeks to get a virtual machine up and running, connected with the storage network. They are adding OpenStack in the data center, but you as an end user, you won't see anything from that. You still need the old interface. But instead of 2 weeks, it might be 2 days to get that virtual machine that you've been asking for. And that's one way of introducing OpenStack. If you call introducing the cloud, if you call it the cloud, you won't be successful because your end users know about the cloud, know public cloud, and they will say, that's not cloud what you're delivering. But if you sell it as a step, as a first step in this long way to OpenStack, to a private cloud, that's one way to be successful. That's one way to solve some of the challenges, introduce it in smaller steps. Other companies are introducing OpenStack as an answer to developers and testers using public clouds and using the shadow IT, as it's called. So for them, a development and test cloud is introduced. And here the challenge is to make your own instance in your data center more compelling than what they have on the public cloud. So it needs to be as fast launching an image there as launching an image in the public cloud, but it should be easier in some ways. There shouldn't be any approval processes, there shouldn't be any ways. If you're developing a special workload, there should be enough automation to help you with that workload and get it running internally. So that's one way of getting this running as a first step in using a private cloud. There are other companies that use a private cloud for some kind of line of business, for some department, where they go beyond dev and test also to production and have that. And play with that, start with that, experiment with that, and go from there. And here the challenge is to go from there at the right time and move it over to internal IT. There are companies that where internal IT doesn't know about cloud installations that are running there. That's probably not the best way of being successful in that. But there's high demand in some of those. And then you have transformational clouds where people are going completely to OpenStack, completely to a private cloud, and want to change everything and move everything into the cloud, into OpenStack. And that is the hardest part, because you change everything, you don't leave anything back, and that means you have to do a lot of political discussions to get everybody on board and can't leave anybody out. If you look at these workloads from another angle, you can also look at enterprise workloads, and if you move to the cloud, see what is the value to the enterprise. Does it give you a high value, or is it low value, and how easy it is to implement. That you can start slowly with things that are beneficial for your infrastructure. So we have there in the middle, as mentioned before, the software development and testing as one way of doing it. And I forgot to put up all the infrastructure I need here. So you have software development and testing infrastructure that you can plug up there and use and get the developers on board, which are technical savvy and are the best way to need the lowest amount of training for doing that. And having them on board will also help you with new business. If they're writing those applications, they know how to do it and get it running. And if you're starting some kind of new business, they have applications written in the cloud way that they work the best way in the cloud and take care of all the benefits that the cloud has. Another workload here is batch and data intensive applications. The Sahara project was mentioned. Hadoop in the cloud is one way for workloads that are data compute intensive, but you don't want to run them the whole time, to do them and scale them up. But in general, peak load demands is also something that you can use the cloud for. And think about, if you're going to migrate to OpenStack, which are the use cases you want to cover. Don't do everything at once. Take steps, look what's beneficial to your company, what's beneficial to your data center, to those users you have, and start slow with them. Another thing, if you're going to OpenStack, is also the organization has to change. It's an organizational and mindset change that's happening in your data center. You want to have data center as a service, and that means the different administration teams working on networking, storage, servers, operating systems, they need to work together and need to collaborate to have one common interface to the user, that he doesn't see anything from that. And also collaboration with the lines of business. And those collaboration, those political fights, that's the biggest impact in introduction. Is setting up an OpenStack cloud can be relatively easy with distributions nowadays. But getting it running and getting it accepted, that's the difficult part. And tuning is another story. You also want to integrate your OpenStack cloud into your existing data center. So you need support for the one storage driver you have that you're already using in your data center for SUSE or for Ceph if you're going for software-defined storage. You want to integrate the networking drivers that you have. You want to integrate IP version 6. You want to integrate some SDN solutions. You want to run workloads on your cloud that are supported in an optimal way. And IT will tell you they need to take care of maintenance. There needs to be a life cycle for all of that. Those are all questions you need to answer going forward into the data center. Thore, you talked with many customers on how to implement OpenStack. What is anything else you learned?
Yeah, one important point we saw there was, on the one side, everyone is interested in OpenStack and looking for how to integrate it and how can I use it. And if you are at this point that you have a pilot running, see, okay, it's usable, you will ask, okay, it's a core business, it's my basic infrastructure. What it's about the availability here? Not only running, you are expect that it's every time running. I can access it to any time. So you have also to look for availability. What is availability? Availability is in the direct time. I want to minimize my downtime. Downtime for services. Services will always need data, so I have to look at the data too. How can we solve this? Normal way, we add redundancy to everything. And in the cloud, we have several layers, several parts we have to cover for this redundancy. If we look at this, first of all, I hope you have some kind of config management admin services which will cover your central OpenStack infrastructure. Takes care of how to install all the OpenStack parts. Itself has no OpenStack services on top. It's only your config engine. So if this will have a failure, the only impact will be that you can't install new resources or reinstall your network. I think most of them are be tolerable, and so it's not so hard to look at this for high availability. On the other side, we have the compute nodes, which will be redundant at all, because you will have them for scalability. And on your compute nodes, you have your guests. As already told, OpenStack loves all the kettles. So a failure of a kettle will not impact the service at all. So we don't have to take care of it. On the other side, we will still have some pets, and from the pets, we can use the traditional methods for high availability. So we will use a cluster, application cluster, to cover this. We only have to make sure that the guests will run on separate compute nodes, so that a single failure can be covered. So this is from the HA perspective, not so high. What we have to control and what we have to really make sure that's available are all the OpenStack services. Because if your control plane will fail, you have still running guests, but your network will be broken. So you may be happy that your compute node is running, but the user can't access your service, and he will not be happy about it. If your storage, which will be provided from OpenStack, is not available, it's fun that your guest is still running, that you have network access, but no writes are possible. So user is unhappy. You're still unable to administrate or use the cloud as itself. So you're not able to start or administrate anything here. So the failure of the cloud is essential to cover for the high availability. Good thing here is that all the OpenStack services itself are designed for scalability. So it's quite easy to install them on multi-nodes. You only need the load balancing before. But besides OpenStack, there are some other services like database, like message queuing, which you have to cover. And for the common idea is to use Pacemaker here and to cover this by this. Pacemaker at all is not as simple as you should know. So it's important to rely here on partners which have the right expertise, how to implement that, and that you're really sure if a failure will be, that the right things will happen. So from the point of availability, we see most point is the control plane. The idea is make sure that guests can be run somewhere. You can still access, the data will be there, storage is available, the API is available. We don't care about a single guest here. we look for the big picture that you can have access to the complete system. And here, really make sure have the right partners, have the right solutions, and test this. It's one of the most important parts. Besides the HA, we have several pilots, POCs done with customers, and we learned some main parts. Some of them, Andreas has already told us. Important for me was always find the right use case and the right workloads. Don't think that it will be a solution for everything. And OpenStack, this is my experience when I come to a customer, why are you using OpenStack or are interested in OpenStack? Okay, management has told us it will solve all our problems. It will can cook coffee, it will manage our cars, and we got a virtualization layer without any costs. And so this is OpenStack not. And so find the right use case where you can start with a small system, a small environment to learn how OpenStack is working and can be used. And very important, try to define goals, small goals and the big goal, so that you're able to measure your success. On the other hand, OpenStack will try to give a standardized API layered for providing resources inside of the data center. My experience is every OpenStack installation itself is special, is different. And so you have to define your architecture, your installation. Start with a small one, start with the core projects like Nova, networking, storage, and add one part after another. Go step by step here. Because the initial cloud setup at all is done quite quickly. So you have it up and running in 1-2 days, but the real work will start then. The integration part, adapting the processes, your workflows, this is the hard way to do. And I think this is most the important point, to look at these organizational and process parts. It's not depending on which OpenStack distribution you are using or which cloud solution at all. If your processes in your company are not fitting to a cloud system, there is no advantage of using a central API to combine all the resources. A private cloud project will have no success at all. We have some successful projects here, and I would like to lead over to Andreas again, so that we can show up a little bit of this.
I'd like to ask Mark Fiedler from Deutsche Telekom Technik on the stage. When I talked with him some time ago, I was really surprised that he not only wanted to set up a single cloud, but lots of different clouds. And so, but first introduce yourself and then tell us a little bit about what you're doing.
Yeah. Hi folks. Hi, my name is Mark Fiedler. I'm working for Deutsche Telekom Technik in Darmstadt. And we are responsible to provide such services like the big entertain platform, mobile fixed services in Germany, and so on. And yeah, we have the challenge to bring new service to the market. They will develop today or produce in traditional ways, network service functions, and that is our main target. To see how we can develop in the future these services in a new way, and that's the big term of the NFV part. And I told you something about our experience with NFV together with OpenStack.
You've brought a video with us explaining NFV. Let me try to put that one up.
in the meantime, we provide or we developed in video for internal and external to describe what's the challenge for Deutsche Telekom in the part of network function virtualization. What is network function virtualization for DT, and what is mean and what is not mean. So, and we will see it shortly.
Sorry. Somehow it worked perfectly fine, but yeah, I need to change the setup. Sorry about that. Give me a minute to mirror my screens and change the setup. As I said, it worked before, but that's how it is.
Technology. Over the decades, our network has grown, constantly expanding and evolving into the best network today, based on an extremely complex infrastructure. This infrastructure comprises network elements from different vendors. They're often designed as technological silos, with network functions linked to manufacturer-specific hardware. That makes maintenance very complex. Developing a new network element requires several additional dedicated test environments. Replacing parts of the network is also expensive, because you have to substitute the hardware and software at the same time. That's why developing software to support new capabilities is automatically linked to the depreciation cycle of the hardware. New innovative services are often produced on multiple network elements, so they go through a long process of development before reaching our customers. The capacity utilization of technological silos is also problematic. The resources have to be designed to handle peak loads, so frequently they're underused. Take, for example, the SMS. It's a reliable service which enables people and devices to communicate. On Christmas and New Year's Eve, the number of messages being sent reaches full capacity. Over the rest of the year, the resources reserved for text messages go largely unused. It's not every day. The people wish one another a happy new year. Virtualization allows us to create the ideal conditions to optimize resource allocation and shorten delivery times. We're talking about breaking down technological silos by disconnecting network functions from vendor-specific hardware, so that in the future they're driven solely by software. Instead of silos, standard x86 hardware components can be used, like the ones customary in data centers around the world. That cuts costs and improves service. Hypervisor is the name of one type of virtualization software that enables the parallel usage of a multitude of virtual machines. It supports the network-related services from various manufacturers that will be provided through software in the future. Data centers at various locations will jointly provide the necessary resources, which can be distributed dynamically and flexibly. For example, if the VPN service for business customers is used less over the holidays, the available virtual machines can be used to accommodate the SMS peaks in the future. This means that new network functions will purely be software solutions, and they can be developed much faster. By delinking network services from the replacement cycle of hardware, new services will reach our customers more quickly. Energy savings, reliability, shorter time to market, and speedier profitability through more efficient use of resources. That's the aim of network virtualization at Deutsche Telekom.
Okay, we're back. So Mark, how is OpenStack playing into this picture? There wasn't any mention of OpenStack in that nice video.
It's a good question. So our experience, our challenge is that, I told this before, that we build up an ecosystem in Germany and also in Europe to provide such services as we has shown, or as shown here in in the video, like the SMS service or hybrid services, or like telco services like the telephony IMS platform, and so on and so on. And yeah, the base or the ground and the base of this platform is actually designed in the architecture. That's the OpenStack. The reason for that is that we need an open ecosystem, or an ecosystem around the hypervisor and the virtualization technologies, that we are able to build up in a flexible way and in a flexible ecosystem of standardized APIs on the north and on the south to build up this ecosystem. In this picture that's illustrated that we have planned to build in 2 types of data centers in Germany as well as in Europe, the front-end data center and back-end data center. They will provide services really near, in the focus of FDC, really near to our customers, and the back-end data center will provide services they are stateful, like the database or storage technologies. That means for data, for content delivery services or video services, we provide streaming delivery services really near by the customers in the front-end data center. That's caching services, they stateless, and the stateful services are stored in the back-end data center. That is one of the slide of the architecture, and yeah, our experience, and Thore and Andreas mentioned this before. We are one of the customers who build up in big POC or pilot in Germany and onboard such services like in our special case the EPC, the Evolved Packet Cords, the backbone, the mobile backbone, and it's a big story, it's a big challenge to onboard these big services on top. And yeah, we have different layers in our architecture. It's the infrastructure orchestrator and application orchestrator. That's the ability to onboard such services like the EPC and to orchestrate infrastructure services from OpenStack.
So how many of those front-end data centers are you planning to build?
We planned in Germany to build up up to 24 data centers in the front end and up to 3 in the back end, up to 2018, 2020.
And you're building up those front-end data centers close to the customers. You're discussing looking at building them up not in the usual data center world, so they might break down. How you're handling high availability of those data centers, of those front-end data centers? Yeah,
the high availability in the front-end data centers is actual plan that the data centers not all built up in HA mode. That means the ability is completely based in the application, and the application orchestrator handle the ability of and availability of this data center. That means is one data center not available, the other one is pick up the service and is managed by the application orchestrator, and that is what we prove and checked in the POC.
So you have some kind of orchestration that moves workloads from, if one data center goes down, right, moves workloads from one to the other?
Yeah.
Okay.
And in reason of stateless and stateful, it's only stateless functions and stateless applications are stored in the FDC. That means no customer data or other functions will be left in case of interruptions, of service interruptions.
And those front-end data centers, what are you using for technology? Using OpenStack? Anything else?
Yeah, we mainly based OpenStack as the virtualization platform. We have such other services, storage technologies. We plan to use Ceph in case of the storage part. And on top, we have an ecosystem of the orchestration layer, and mainly based on the ETSI.
Is this a real private cloud, or is this something special? So can any end users or anybody at Deutsche Telekom say, I want to run something on that environment?
They can, but I think it's not really a private cloud. The customer layer to use this infrastructure is based on the orchestrator. In terms, we would like to provide applications to our customers. So our customer has the application department, and they will onboard in different ways this application. But we planned also to integrate Murano as an application, a portal, and to have the flexibility to integrate these applications there.
Are there any special lessons that you have learned in setting up this pilot?
Yeah, it's really different to onboard such different services from different vendors. Every vendor or big vendors in the telco business has their own solutions, and it's not really simple to integrate all these different solutions on one defined architecture from our side. That means we have special requirements on the network, on the storage part, and also on the compute side. But yeah, one of our learnings was that it's good to describe that we have a standardized way, like the Tosca or the heat format, to onboard such applications in a standardized way.
Okay. Thanks,
Okay.
Mark.
Thanks.
Let me go back to Thore. Thore, you have every use case that is completely different. Here
Yes.
it's a new workload, special purpose, NFV, but you are also known in the legacy world. So can you tell us a
Yes.
little bit more about that?
Yes, I wanted to talk a little bit about a customer called FIS-ASP. FIS-ASP is an SAP hoster. We as SUSE are quite common to work with SAP. It's, by the way, the development platform for SAP. And FIS-ASP is an hoster which takes care of all stages of SAP application for a customer. So providing only SAP base, they're providing SAP consulting, they have own solutions based on SAP which they sell to their customers. They're using Linux since 2004 as their platform. For providing the SAP service and for the virtualization. So they're running Xen for their virtualization solution, and are still, and since they're trying to automate and standardize their operating as much as possible. So cloud is interesting for them as a resource and automation tool. Start evaluating cloud solutions in 2012 and jumped to OpenStack a year later. They tried to install Grizzly by themselves, vanilla, and realized that OpenStack is not really simple. So they ended up with a dev stack and say, okay, it's up and running, but that's not really a productive way to operate it. And so they asked us as their Linux distributor, can you help? And we had our OpenStack distribution set up a pilot in one day. And so they were able to see, yes, it's productive ready. They can use it. And they found some use cases which they want to use to learn how OpenStack is used and how they can, or what changes they need for the operating. First use case is to use it for evaluation systems. So if a customer of them asks for, I need an SAP system, can I test how stable, how the software can be used? They need a system to provide fastly and test system for them. And this is a use case for the OpenStack, the automation to provide a complete SAP environment for a customer to say, okay, here is it, use it for 3 months, and then we have a look if it will fulfill all your requirements. Second easy use case is for training. So to build up training environments for SAP, it's a good use case. And you see all these use cases are not so hard in the mission critical environment. So if they break, no real company data will be lost or interrupted. But they want to use these use cases to learn more about scalability and how to use it. And the last use case for sure is to have it in a productive way. what they have learned in this time was, first of all, yes, OpenStack is not simple. They use the distribution so that there is a central config management. They rely on our best practice for this. And they want to have one single support contact. So to have their operating system for their workloads, SAP, mainly from the same vendor or same distributor as the cloud infrastructure. One caveat was from their Xen experience. They know SAP is really intensive of I/O load. They have a big SAN infrastructure for providing the I/O for the databases. And they tried this for the OpenStack part. And they realized that OpenStack is quite IP-based from the storage side. So they tried it with a Ceph cluster, but the trust is not so high in this technology currently. So they are looking still for a SAN technology to provide all the databases. And it's not the best support on our OpenStack currently. We want to help here. Okay, I think this is what a quick view on a traditional solution. Andreas, I think you have additional one.
I have another one. I have Data Launches, which is a Finnish hoster that is a traditional hoster in some ways. And they extend the data center of their customers in a virtual way using OpenStack. Some of their customers are Microsoft development partners that use the extension of the data center for testing and development, for testing updates. They use it for public website sharing, for sharing of files. They decided to go with OpenStack because of the great community and also the commercial support they get. And the customers like the flexibility and the stability that it gives them. They are in production since March now with Juno base. They use both Ceph and Swift. They started first with Swift to only allow the sharing of data and are using now Ceph as a backend in the architecture for the volume storage. I think they are going to switch completely to Ceph at one point. One challenge for them is monitoring and reporting. So they do something here with Oscillometer, had to extend that to get it ready for their use case. And they also do offer their customers VPN as a service into their customer data centers. And if the customers don't have any VPN set up, they also offer them a Raspberry Pi with VPN running on it, OpenVPN running on it, connecting to the OpenStack instance. It's a small installation at the moment. I hope they plan to grow it. The challenge that they had was on the hardware side, a fully redundant fiber channel setup to get that everything running and integrated with Ceph and with the compute nodes. Ceph performance was initially a problem. They did some tuning on that, and now they are happy about that. And usage reporting for customers so that they can drill down and figure out how much data is used, how much traffic is produced. That kind of reports, that's something they are working on and plan to release an open source project for that as well. Okay, I think we are running out of time, so I'm skipping the next use case I had here, and let's sum up. OpenStack has arrived in the data center today, as also Mark explained with some other examples. It has arrived like Linux has before, but if you look at the speed that OpenStack has arrived in the data centers is used, it's nothing like Linux. It has a much higher momentum, and I advise you to start now, look at it. It can be complex, so work together, find experienced partners that you work with, or build up the experience in-house. It's not a solution for everything, at once. My recommendation here is to start with clear goals and expectations, what you want to solve, have small milestones, successes, and go from there to finally have it in the end for everything it needs. And most important, it's software. What software needs to be used, it needs to be adopted. So it will bring changes to your processes, it will bring changes to your organization. Prepare for that and be cloud ready. So that's part of the presentation. We have a booth outside and we will have a prize draw at 4:05. You fill out one of those cards that you can get there. That's enough of the commercial side from my side. Thanks everybody.